Hello, everyone, and thank you for joining us. My name is Juliet, and I will be the moderator for today's webinar. Before I pass it over to our speakers, let me cover a few housekeeping items. At the bottom of your screen are multiple engagement tools you can use. All tools are resizable and movable, so feel free to move them around to get the most out of your desktop space. You can expand your presentation area or maximize it to full screen by clicking on the arrows in the top right corner. If you have any audio or video issues, you can find answers to some common technical issues located in the Help widget at the bottom of your screen. Please note that a copy of today's slide deck and additional resources are available in the resource list. Please have a look and download everything that you may find useful. Also, the webinar will be recorded and sent via the email you registered with. Now, lastly, if you have any questions during the presentation, you can submit them through the Q&A widget. We're here to answer you live via the chat, so don't hesitate to reach out throughout the presentation. Now, I'd like to introduce our speakers. Today, we're joined by Jody Nelson. Jody Nelson is the co-founder and managing partner at SecuRESafe, SRES, with over 20 years of experience in automotive safety. Jody has made a significant contributions in development, consulting, assessments, and audits. He approaches every project with the passion and dedication that he would for his own family and friends, ensuring the highest standards of safety. Earlier in his career, Jody worked at Dalmir AG before co-founding the safety consulting firm KVA, which was later acquired by UL Solutions. There, he led the global efforts in functional safety, cybersecurity, and autonomy. His wide-ranging experience enables him to provide deep, practical support to clients across the country. We're also joined by Matt Mickle. He's the Director of Automotive and Semiconductor Solutions at Jama Software, with a focus on providing solutions and consulting to the unique needs of this market. He has over 10 years of experience with working with hundreds of Jama Connect customers on their requirements and systems engineering processes. He moved from the US to Europe in 2017 to help start and build the team at Jama Software's EMEA headquarters in Amsterdam. And with that, I'll pass it over to you, Jody.
Thank you. Appreciate the invitation from Jama for this discussion. I think it's a very important topic as we're going to be talking about a newly released standard, the ISO Pass 8800. And our agenda for today, we're going to first start out and talk about the framework and importance of the 8800. In order to do this, we have to pull in other standards. So as we'll discuss in this discussion, the 8800 is not a standalone standard. It does have dependencies on ISO 26262 and ISO 21448. So we'll start out kind of from some framework for ADAS, automated drive systems, and then we'll go into deriving and managing AI safety requirements. And this is a very difficult topic to go through. So this is where it's really great in this partnership with Jama to walk through it with a requirements management tool because it's much easier to see once we're in a tool environment. And then we'll talk about this addressing insufficiencies. This is something that we talk about a lot in SOTIF. Now we're going to drive that down into lower levels into the AI system, including down to the machine learning model level. And with all of these safety standards that we talk about, and with all these kind of aspects of safety, we need traceability. So, we'll talk about in 26262 traceability between requirements to verification testing to your safety analysis. And these are kind of the aspects that we want to show in today's webinar. And then we'll actually jump into the tool itself and kind of show you a practical example of how to use 8800 and just show that kind of flow. So before we get into that, I do want to lay out a little bit of an AI requirements landscape. And before we jump into the AI safety kind of landscape, let's take a step back because it's very important that we harmonize and ground ourselves with where we're at now prior to these kind of AI safety standards. Well, the automotive functional safety development, as most of you know, the ISO 26262 was released in November of 2011. We have this kind of pyramid of development, and it's very common. And one of the biggest advantages of 26262 is almost everything's built into the standard. So we don't look out of the standard much when we're in the traditional functional safety world. It's all built into the standard. Well, we start out with this QMS layer, this quality management system layer. And that's the one exception to that last statement. This is where we point out to an outside standard such as ISO 9001 IATF 16949. These are the most commonly used in automotive. And that sets up our basis for our quality management layer. So that's setting the initial processes. But that's not sufficient enough for safety. So we build on top of that functional safety processes, functional safety policies, which we call our functional safety management. And the majority of that is captured in part two of the standard ISO 26262. So that's the layer that we build on top of the QMS. And then, of course, we need a path forward. We need an understanding of the steps that we need to follow. And this is within our functional safety lifecycle. Again, this is built within the standard. We can jump into part two of ISO 26262. It provides us an overall life cycle from concept phase all the way to decommissioning. So we're talking about 15, 20-year lifetime. And then on top of that is where we do the actual development. And that's where in the standards, parts 3 through 7 goes into the concept phase, driving functional safety requirements, technical safety requirements, driving down into your hardware and software, and then coming back up to this V cycle where we do verification and eventually validation. Now, this framework is well established. As I mentioned, since 2011, we've been following ISO 26262, and nearly the entire framework is built in. As we transition into autonomous drive and to AI safety, it gets a little bit less clear and less straightforward as this. So I readapted that first pyramid and looked at now the AI safety aspects of our development in automotive. So in the bottom layer, we're going to have an AI management system. So we're still going to use our 16949 or 9001 QMS, but we need to extend beyond that. And what was released in 2023, late in 2023, is a standard called ISO IEC 42001, which I'll discuss briefly today. This sets up the nuances that we need to consider when we're talking about AI. Data governance, ethical concerns, all these kind of responsible AI aspects are included into this framework of the 42001. 42001 is not meant to replace 16949. It's meant to play with it, to work together with your QMS. So it's not about getting rid of your QMS processes. It's about adding in the inclusions for our concerns or relevance with AI. Well, just as we had in functional safety, we have to build in an AI safety management on top of that. Now we're going to start pulling in, for example, ISO PAS 8800 that we'll be talking about today, but in conjunction with the 26262, because 26262 still helps us establish the safety management. 8800 gives us the specific aspects of AI to that. And then our life cycle, we will be following aspects of 26262 life cycle, but also SODIF. So the ISO 21448 will be a critical aspect as well, because we're going to be combining both of these ideas into what will lead into the aspects that we need for the ISO 8800. So all three of those will be incorporated and to build in this AI safety lifecycle. Then, of course, for the AI safety development, we're going to have aspects of 26162. We're going to have aspects of SODIF, 8800, as we'll discuss today. And then we have some kind of complementary standards that will help us round this out. The ISO IEC 5469, this will be replaced by an actual technical standard in the future. But as of now, this is a technical report. It is informal, so it provides us only guidance. There's no shalls or requirements in it, but it's going to help us. And we'll see in the 8800 as you go through the standard, it points out to 5469 in some cases, and then soon to be released or currently released, the ISO 5083, which will be our replacement to the ISO 4804. This will help, again, align to ISO 26262 to that V cycle, that V model that we're commonly used in 26262 world, but will help us with kind of more of the verification and validation activities in autonomous drive. So I called this kind of the new automotive model. As I mentioned before, we do have to point out to a few other standards. I do understand there is, in some cases, standards fatigue. We're trying to boil this down into kind of the most condensed version that we can present here. So just briefly, I'll look into a couple of these standards. As I mentioned, ISO IEC 42001. If you're not familiar with this, it was released late in December of 2023. It is agnostic to industry. It's agnostic to size of company, and it's for both organizations that use AI or that develop AI. So it's a very broad standard. Again, it is kind of our QMS layer, but with the specific aspects of AI that we need to talk about. So it helps us ensure this responsible development of using AI systems. It does address ethical considerations, transparency, safety, and security. But it does provide a risk-based approach. Um, Most of our functional safety standards and safety standards that we talk about in automotive are a risk-based approach. So within 42001, we talk about risk analysis, risk assessments, risk treatment, how we're going to control these risks, and then an impact assessment of the overall risks that remain. So that's kind of our bottom layer. And then I just wanted to point out the ISO IC 5469. Again, this is informative, meaning there's no shells in the standard or in the technical report. It just provides us guidance and draws in this connection between functional safety and using AI systems, either as a safety mechanism or somehow the AI system can impact safety. How do functional safety and AI systems interact? It is agnostic to industry. Built into the standard, they use mostly the IEC 61508 as the basis for functional safety. Of course, us in the automotive world, we can easily translate that into the 26262 perspective. So it does describe some properties, relate some of the risk factors and some methods and techniques. It goes into tools that are developed using AI. How do we handle that? So it has some more specifics there that we don't have in ISO 26262 Part 8, where we generally talk about tool qualification. So it expands that discussion. Actually, the 8800 will point to the 5469 when it starts talking about AI tools being used in your development. And as I mentioned, it will be replaced eventually by the ISO IEC 22440. This will have then requirements and more of a shall kind of a standard. So let's transition into specifically the 8800 as titled here, Road Vehicles, Safety and Artificial Intelligence. This was released late here in 2024. So we're talking about a standard that's only 3-4 months old at the moment. And it does provide us now industry specific. And when I talk about industry specific, I'm talking about automotive for us on guidance of using these AI systems, especially when there's a safety related function involved. So really specific to the safety aspects of AI. Now, as I mentioned before, it is not a standalone standard. So you do have to have kind of a deep knowledge in ISO 26262, a deep knowledge in SODIF to really use 8800 appropriately. So we will talk about that, about the tailoring and extensions that we needed to do with 26262 and SODIF. And it's applicable to any kind of AI method. So it's not, specific to a certain method. And we're talking about all these different AI elements. And specifically right now on board of the vehicle, we can have other discussions about off board, as we move into the cloud and the functionality in the cloud and its impact on ADAS and automated drive. But the standard specifically is for onboard. So it addresses these risks of undesired safety behavior, due to, we'll talk about functional insufficiencies. Those of you that work in the SODIF world, you've heard that. Well, we're going to talk about it in a little bit different aspect, different abstraction layer of that same kind of concept. We're going to deal with systematic errors, right? Systematic errors are errors that us as humans introduce into the model, introduce into the requirements, into the verification testing. Somehow we built in a failure or a fault into the system that we're designing. And then does have aspects of random hardware failures when those can impact our ML model, our machine learning model itself. So just a little bit of a layout of the structure of this. Clauses 7 through 15 are normative clauses within the standard. There's a number of annexes. Those are all informative. We start out in the standard with clause 7, and this helps establish our AI safety management. This is what I showed previously in that pyramid. We're going to use 26262 again to help support this, but we have extensions that are required when we're working specifically with ML models. We just have different ways of developing ML models than we would in a traditional software environment. And clause 8 is kind of, it's presented early in the standard, but it's really building up all these assurance arguments.